Hi everyone, today we'll look at some simple questions on the topic transposition of formulae. Here we have three exercises. The first one, root 4ag all over L is equal to 2b. How do we make A the subject? We are asked to make A the subject in each of these formulae down here. So if we take the first one, root 4ag all over L is equal to 2b. We want to make A the subject of this formula. The first thing to remove will be this square root sign. Okay, to remove the square root sign, all we need to do is to square both sides. And so we square this and we square all of this. Okay, we should be very careful not to come at this level and we write like that. If we write like that without the brackets, it means the square will affect only B and it will not affect 2. But it's supposed to affect both B and 2. Therefore, we put the brackets. All right, we know that the power 2 or square cancels square root. So here we have 4ag all over L is equal to, this power here affects 2 and affects B. So 2 to the power 2 is 4. And then, of course, B to the power 2 is B squared. Remind you, we are looking for A. We want to make A the subject, or we want to solve for A. This is a fractional expression. We can just make this a fraction also, and then we'll carry out cross multiplication. 1 multiplied to that up there, that numerator will have 4ag. L multiplied to that numerator becomes 4b squared L. So the last thing to do now is to remove 4 and g. How can that be done? We just divide both sides by 4g, so that you can see the 4 has gone and the g has gone, and we now have the expression for A. A is, in this other side here we see 4 goes, so A is B squared L all over G. If we take the second exercise, we have 14 all over root 2abp is equal to 7 all over root p. The square root sign here is only with the denominator. It does not include the numerator, just like in this other side. The square root involves only the denominator and does not include the numerator. So we can still go ahead and square. We go ahead and square to remove the square root. But if we look again at the numerator, we have here 14, we have 7. There is a common factor. 7 is a common factor. So if we divide both sides by 7, so we're saying 1 all over 7 is the same as dividing both sides by 7. 1 all over 7 is the same as dividing by 7. If we do that, then we see 7 there 1, 7 there 2, 7 there 1, 7 there 1. So our expression reduces to 2 all over root 2abp is equal to 1 all over root p. Now at this level, we can square both sides in order to remove the square root, or have square root on the left hand side, square root on the right hand side. So if we square this and square that, we obtain 2 squared is 4. The square and the square root sign cancels off, and we have at the denominator here 2abp is equal to 1. 1 square is 1, and then the square and the square root sign cancels, and we have 1 all over p. Keep in mind, we want to make A the subject. But at this level, we can see that 2 cancels, and so we have 2 all over abp is equal to 1 all over p. Now we have a fraction equals to a fraction, so we carry out cross multiplication. P multiplied to 2, we have 2p. abp multiplied to 1 is simply abp. We want to have A alone, so we have to remove BP. That can only happen if we divide both sides by BP. If we divide both sides by BP, on the left hand side here, P cancels. We have 2 all over B. On the right hand side, B cancels B, P cancels P. And so the expression for A will be 2 all over B. Now let's look at the last one. The last formula, we have 1 all over V squared minus 1 all over A squared is equal to 1 all over P squared. We want to make A the subject of this formula. Here we have negative 1 all over A squared. We don't want to work with negatives, so we simply carry it to the right hand side and take this expression 1 all over P squared that was on the right hand side to the left hand side. Remembering that each time we are crossing the equal sign, we multiply by a negative. So here we have 1 all over V squared. This is 1 all over P squared. Bringing it over this way becomes negative 1 all over P squared. This is negative 1 all over A squared. Carrying it over, it becomes positive 1 all over A squared. At this point, we see we have two fractions here, so we should bring them to a common fraction, one common fraction. So we look for the LCM. The LCM of V squared and P squared is simply V squared times P squared. V squared times P squared. So when we take this LCM divided by V squared will cancel V squared and we're left with P squared. P squared times 1 is P squared minus, we take the same LCM divided by P squared. P squared will cancel P squared, we're left with V squared. V squared times negative 1 is negative V squared. It's equal to 1 all over A squared. Now, we see 1 all over A squared and we are interested in making A the subject. This is 1 all over A squared. It simply means that if we take the reciprocals of both sides, what's the reciprocal again? Pay attention. If we have A, then the reciprocal of A will simply be 1 all over A. If we have 1 all over B, then the reciprocal will be 1 all over 1 all over B, which is simply B. Okay? So, if we, oh my God, maybe let's write it again, let's do it again. If we have A, then the reciprocal of A, reciprocal will simply be 1 all over A. If we have 1 all over B, then the reciprocal will be 1 all over 1 all over B, which is simply B. Now, let's have this at the back of our mind. So, if we are taking the reciprocal of the left-hand side, it will become 1 divided by all of this. The denominator simply moves up, just like we had here. The reciprocal of 1 all over B, the denominator simply moves up, so it becomes B all over 1. So here we will now have V, P, all of that squared. Since V squared, P squared, they all have the same power. So by the law of indices, since the powers are the same, V squared, P squared will just be the same as V, P, all of that squared, divided by P squared minus V squared. And if we take the reciprocal here, we'll just simply have A squared. Okay, so now from here, we need to remove the power 2 or the square. To remove the square, we take the opposite of squaring. The opposite of square is square root. So we're going to take the square root of both sides. So if we take the square root here and take the square root there, then we end up with this square root cancel that square. We'll have A, which is equal to the square root of VP squared all over P squared minus V squared. Now, this simply, we can see square root and square. They are direct opposite operations. They cancel out. So this square root, well, this is the same as square root VP all squared all over square root P squared minus V squared. So this simplifies to The square root and the square cancels. It simplifies to VP all over root P squared minus V squared. So that would be the expression for A. We should be careful. Up there, the square cancels the square root. But down here, even though we have square and we have square and square root, they do not cancel out because we have an operation which is not multiplication between P squared and V squared. Here we have subtraction. They will cancel out only when we have multiplication like we have here. Here it is V multiplied to P. Okay? V multiplied to P all squared. When the operation is multiplication, then the square root will cancel the square. The square root here does not cancel the squares here. Thank you.